Hi guys, I hope everything's going well with your digital learning. Be sure you email me if you have any questions. Today we're going to talk about a lesson 11.2, day 2. Does labeling menus reduce calories? So our scenario for today is, according to the Stanford Business articles, Americans may eat fewer calories at restaurants if the calories of the food items are labeled on the menu. To investigate this, researchers compared Starbucks receipts from locations where the menus were labeled to receipts from stores where the menus were not labeled. A random sample of 30 recipients, from stores with menus labeled had an average number of calories of 225 calories with a standard deviation of 100 calories. A random sample of 40 recipients from stores without menus labeled showed an average of 265 calories per receipt with a standard deviation of 75 calories. Does this provide convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than at a Starbucks without a labeled menu? So, as we go through this, you may want to pause the video before I start to try a section and see how you did compared to me, and you can make some notes and add in. That's just a good way to make sure you're understanding kind of all the pieces that have to be included with each section. So for our parameter, we want to take mu1 minus mu2, and that's going to equal the true difference in mean calorie intake and I am going to do labels minus no labels. So that is mu2 and this guy is mu1. All right. So our statistic that we're interested in is x bar 1 minus x bar 2. So x bar 1 is the one with calories labeled, which is 225. X bar 2 is without the labels, which is 265. So I'm going to get a mean difference of negative 40. Our significance level, it doesn't say in there, so we're going to go with alpha equals 0.05. And our hypothesis is the null, meaning no difference. And when I subtract them, I'm going to get no difference. And my alternative is when I subtract them, I'm going to get less than 0. All right. All right, so the name of our procedure is we have 2 independent random samples. So this is going to be a 2-sample t-test for mu1 minus mu2. Okay, so here's a good place to pause to see if you can get through these conditions and then come back and see how you did. We have random. Say we had random samples. Of 30 and 40 receipts. Okay. We had our 10% rule. And so we had one sample of 30. Well, 30 is going to be less than 1/10 of all receipts at that store, and 40 is less than 1/10 all receipts for the other store. Okay. Then we have our normal. Thankfully, these numbers are going to be a good size. So we have one sample that was 30, which is greater than or equal to 30. So we have CLT. And the other sample of 40, which is greater than or equal to 40. So again, we have CLT. So we're good there. So our do part. so we need to know our mean. So to find the mean, we're going to use mu here because we're talking about the parameter. This is coming from our null. We're saying mu1 minus mu2 is, there is no difference between them. That's what we're going with the claim. And our standard deviation. So our standard deviation, our information is coming from our sample, so it's really a standard error. All right, so for here, we've got 100, and that's going to be squared over a sample size of 30. And then we have our other standard deviation is 75. We're going to make it a variance over its sample size of 40. And when I worked it all out, I got 21.77 for my standard deviation. So your general formula, that's where we were writing in Word. So to find your test statistic, you're going to take the difference minus the null and divide it by the standard error. Okay, so in a little more official looking formula, that's t equals x bar 1 minus x bar 2 minus mu1 minus mu2, all divided by your standard error. So in this example, we're going to get the difference of negative 40 minus 0, because that's our null claim, divided by 21.77, and I got a z-score of, or t-score, negative 1.84. All right, so that's our test statistic. Okay, let's draw our picture. Mean would be at 0 because that's what the claim is. And we got negative 0.184. So we're looking for this probability right here. And this is a t distribution, and our degrees of freedom would be 29, or sorry, 29, which will work. We can use that one. And we don't have to round down. All right, because our score here was negative 40. Our p-value, so remember, so we have a degree of freedom of 29, all right, and a t-score of negative 0.184. So on our table B, we only have positive t-scores. You just assume it goes with the negative. And with a degree of freedom of 29, we go across until we find 1.84, which occurs right here between these two lines. So when we follow that to the top, that's 0.025 to 0.05. So 0.025 to 0.05. All right, so it's okay to be equal to alpha. You cannot exceed alpha. So our conclusion here, here's a really good spot to pause it to see if you can write the conclusion and then compare it to what I've got. So this one's long, assuming there is no difference in the average number of calories between stores, assuming there is no difference. All right, rather than listening to me write it all out while you write it, you can pause this while you're looking at this. So assuming there is no difference in the average number of calories between stores, there is a 0.025 to 0.05 probability of getting a difference of negative 40 calories or less purely by chance. Because our p-value 0.025 to 0.05 is less than or equal to alpha 0.05, we reject the null. There is convincing evidence. There is convincing evidence less calories are consumed when calories are labeled. All right, so hopefully you're remembering a lot of our processes here. What's special about this is we're using the t distribution. So we have to remember here that this is not a normal curve, it's a t distribution. And otherwise the math kind of looks the same way as what we were doing, and it is a little bit different when we look it up on our table B. Okay, to summarize our notes today and see if we met our learning targets. Here we go. So when you're finding your t-score, your test statistic, you take the difference in the statistic minus the parameter, which is the null, which is almost always 0, and put it over the standard error of the statistic, which is the standard deviation. And then when you find your p-value, it's a t-score. Look for your t-score range on table B. Draw your curve. Whatever your mean is, whatever your null is, goes here in the middle. You'll put your score wherever it falls in here, and you label it T, degree of freedom. And that should get you going. Your assignment for today is to complete this Check Your Understanding. When you have finished it, take a picture of it and upload it to the assignment of the same name. Email me if you have any questions. Talk to you later.